Well, happy Thursday, everyone. Hey, it's your last day of school before a long weekend. So I know that's exciting. I hope that your day has gone well. And let's go ahead and jump right in on what we're going to do today. I want to go over last night's homework. So go ahead and get out that imaginary numbers homework that you guys got yesterday. I know you guys did really well with this. As we were going over it, I could tell you guys were just knocking it out of the park. You weren't going to have any problems. So let's get into it and make sure you didn't. Remember, the thing that we had added from the previous night was when you have that negative that's inside that radical, it comes out as an I, right? So number two, that negative is going to come out as an I. And then, of course, the 324, since it is a perfect square, the entire thing escapes as an 18. If you have your perfect square list, you'll see it there. If not, don't forget that you can always check to see if it's a perfect square by simply typing in your calculator square root of. So second x squared and then 324. And sure enough, you would see it is a perfect square. Okay, here's number 4 and 6. On number 4, of course, the negative comes out how? As an I. Okay, easy stuff. We talked about that yesterday. The 44 is where we start dedicating our attention. 44 is not a perfect square. And as you can see here below, the biggest perfect square that comes out of 44 is 4. And it comes out 11 times. So 4, being a perfect square, gets to escape as a 2. So we put it in front of I, and then, of course, the 11. It gets trapped inside. So there's your answer, 2I times the square root of 11. Here's number 6. Again, the negative comes out as an I. 288 is not a perfect square, but 144 goes in there twice. So 144 is that biggest perfect square that went in there. It shouldn't have taken you long to find it either, because you can see there it's just divided by 2. So the 144 being a perfect square, it escapes as a 12. The 2 gets trapped inside. So 12 times the square root of 2. I'm sorry, 12I times the square root of 2. My fault. Number 8, if you guys recall, I told you to take out that square root of negative 5 that is missing from my page, and hopefully you guys did that. If you break those down, this square root of negative 6 will only break down to I square root of 6, as you can see directly below it. But the square root of negative 12, the negative, of course, comes out as an I, but then 4 will go into 12 3 times, and 4 is a perfect square. So here you have 2I times the square root of 3. Well, then I'm able to multiply those two. If you notice, they're highlighted here in the yellow. I times 2I really becomes 2I squared. Now, hopefully you guys recall from yesterday, what is the value of that I squared? Well, it's negative 1. So this really is 2 times negative 1. And sure enough, you see that right there. Negative 2. And then, of course, the 6 times 3 inside the radical becomes 18. Well, 18 can now reduce. 9 goes into it twice, and 9's a perfect square. So all of a sudden, and you follow it up here, you're left with negative 2 times 3 square root of 2. Well, now you can multiply the negative 2 by 3, and you get negative 6 times the square root of 2. So that one was pretty hard. That was probably the hardest problem on this entire assignment. So if you got that right, pat yourself on the back. Well done. Number 10, I ask you to omit. Yours said I squared. Mine said I to the 49th. That's why I had you. Omit that problem, because I thought y'all said the same thing mine did, but it didn't. Here you have 8I times negative 9I. Don't forget, the way that worked was 8 times negative 9 is negative 72. And then I times I is I squared. And remember the value of I squared? Negative 1. So negative 72 times negative 1, that's how we get that positive 72 over there as my answer. Okay, 14 I asked you to omit. 16 I wanted you to do. Look at the work here. I divided by negative 3. That's how I got the negative 50. Then I took the square root, and remember the rule? Because I added that square, because I took that square root, I added that plus or minus to the answer, and then I had to worry about breaking down that 50. Well, 25 is a perfect square. It goes into it twice. So that breaks out as a 5. So 5i times the square root of 2. So my answer, x equals plus or minus 5i times the square root of 2. Okay, number 18. I had to subtract 18 first. So 39 minus 18 is 21. Then I had to get rid of this little negative that came down, if you notice. And I did that by dividing by negative 1. So that gave me negative 21. Then I took the square root of both sides. I added a plus or minus for that. I pulled the negative out with an I. And 21, I know it's divisible by some things, but it's not a perfect square, and no perfect square goes into it. So that's how your answer is left. So that's number 18. Here's number 20. This had a lot going on. You had to add 15, so 216. Divide by negative 4/3, so negative 162. Then I took the square root of both sides, as you can see. So I added that plus or minus to my answer. Negative came out as an I. And then, of course, we had to focus on how do we break down 162. So as you can see right here, I broke it down using the biggest perfect square I could, 81. It went in there twice. So since 81 is a perfect square, it gets to come out as a 9. And then, of course, that 2 just gets stuck right inside. Nothing you can do about that. Just leave it be. So there's my answer, plus or minus 9i times the square root of 2. And then I wanted you to try number 28. I hope that you tried it. We talked about how you work backwards. So you set it equal to x. Then the opposite of taking the square root, we square it. So x squared is what I'm left with on the left side. And then we got to start just multiplying all this. Hopefully you recall this from yesterday. That plus or minus, when I square it, just becomes positive. So there's really no reason to put a sign there. 8 squared becomes 64. I squared becomes negative 1. And the square root of 3 squared, the square roots cancel with the square, and it just becomes the 3. And then I just multiplied all that. 64 times negative 1 times 3 is negative 192. And the last step is just to bring it over by adding. So hopefully, when you did this, you got x squared plus 192 equals 0. If you did, great job. In fact, hopefully you got more of these right than you missed. If you did struggle with one, like I said the other day when y'all had to watch one of my videos, go ahead and put an asterisk by one that you struggle with. And when I return, make sure you ask me about that because I want to make sure you understand it. I think you guys did really well today in class, but in case you didn't and you need some questions answered, I will go over it. Okay? Now, at this point, we're going to go into our new lesson for today, which again, I think you're going to do well with, and it'll be the way that we finish out this week. It's called complex numbers. So at this time, hopefully, if Ms. Stevens has not given you the paper, she'll be passing out to you guys this complex numbers note sheet. Complex numbers note sheet. All right, so we'll go ahead and start going over this. Some of it really, really simple. Others of it, it's not too bad. I think you guys will do really well. So let's go ahead and get started. Complex numbers. Now, if you can read this, it says consider the number 5 plus 2i. Because you have a real part, 5, and you have an imaginary part, 2i. They are not like terms, and therefore you can't combine them. Okay? Therefore, when we sit them out there next to each other like that and we can't combine them, that makes up what we call a complex number. And the standard form of a complex number is always going to be written like that. Your real part is going to be first, and then your imaginary part is going to be second. So it's going to be in the form a plus bi. So when we do all these problems that we're going to do today, we're going to make sure that the end result is in that form, the standard form of a complex number. All right, so let's look at some of these. If you look at number 11, you've got two complex numbers here being added together, and that's a key. when it's being added, no signs are changing. You're just combining your like terms. Now, I personally like to show this method. It's called vertical addition. And the reason I like to show vertical addition is because, in my opinion, it helps you keep things organized. It helps you making sure that you're only combining like terms. So I want to show you this today. You absolutely do not just absolutely have to use it. And I know I just said absolutely like 3 times in a row. But I think it's useful, especially when you struggle. So let me show you this. I'm going to take that first complex number that's already in standard form, but I'm going to go ahead and keep it in standard form. If it wasn't in standard form, I would have written it in standard form. And then, like I said, because that's a plus sign, that other complex number does not change. That remains a positive 9, and that remains a positive 2i. So vertical addition just allows me to place my like terms directly above each other. That way I know that I'm combining like terms and that I'm combining them correctly. Like, for example, negative 11, positive 9. 9 minus 11, or negative 11 plus 9, is negative 2. That's my real part. But what about 3i plus 2i? Well, that's positive, so plus 5i. So now I have my answer written, and it's in standard form. Negative 2 plus 5i. And that's it. That's all you got to do with these. Okay, look, that's how easy number 2 is. All right, I'm going to write my first one down, 4 plus I. I see this plus sign, which tells me that none of my signs change. So that's going to be a positive 7, and that's going to be a negative 5i. I place them directly underneath their like terms, and now I combine. What is 4 plus 7? 11. And what is positive 1i minus 5? What's 1 minus 5? Negative, so minus 4i. So my standard form of this particular problem is 11 minus 4i. Okay, let's scroll on down to number 3, because all of a sudden we run into just a little trick. See, I'm going to write my first one down just like I did, 7 minus 2i. But here's the trick. That sign is no longer a plus, it's a minus here. We're actually subtracting this one. So why does that make it more complicated? Well, it doesn't make it more complicated, does it? But it does cause us to do something sometimes we forget. That negative is like having a negative 1 outside that parenthesis that needs to be distributed to everything inside of it. So what that means is it's going to cause our signs to change. That's not a positive 2 any longer. That negative is going to make it a minus 2. That's no longer a plus 6i. That negative is going to make it a minus 6i. And this is where I believe the vertical addition really helps me, because now I'm not looking at that problem on the left anymore. I'm looking at the one on the right. And I've already changed my signs. I have them on top and below their like terms. So now all I got to do is just combine. What is 7 minus 2? 5. That's my real part. And what's negative 2i minus 6i? Well, that's negative 8i. That's my imaginary part, and that is my answer. So we're simply combining like terms with these things that we call complex numbers. Let me show you one more, and then we'll move on. You got 6i. What will that minus sign do? Say it with me. Change signs. So what will it do to that 14? It'll make it a negative 14. Now, why did I put it out front? That's my real part, okay? Now, last, what will that negative do to that negative I? It'll change it to plus I. But then all of a sudden we have a plus, so that won't change signs, right? That'll stay positive 5, and that'll stay minus 3i. So let's work vertically. Start with our real part. What is 5 minus 14, or negative 14 plus 5? Negative 9. That's my real part. Then going down the right side, what's 6i plus 1i? 7i. What's 7i minus 3i? Positive 4i. So my answer is negative 9 plus 4i. That is combining like terms when our terms are complex numbers. Okay? Moving on to a new concept. This one is multiplying. Now, we're not going to do anything here that's just crazy difficult. But I do want you to remember one major thing we talked about yesterday. I squared equals what, guys? Negative 1. That's going to make a major impact when we multiply and imaginary values are involved. All right, so here we go. And I'm going to utilize this top right corner to write my answers vertically. Okay, let me explain. What is 2i times 8? That's 16i. And then what is 2i times negative 3i? Well, 2 times negative 3 is negative 6. And what's I times I? I squared. Now, you might look at this problem immediately and be like, hey, hang on. This does not look like it's in standard form. Or you might look at it and be like, hey, hang on, that I should be at the end. Well, let's fix this. What do you notice that we know that will cause this problem to change? I squared equals negative 1. So what will that negative 1 actually do to that negative 6? Well, it'll make it positive 6. So sure enough, here's my answer in standard form. Which one of those is my real part? 16i or 6? 6 is. And then the plus 16i is my imaginary part. So my answer in standard form is 6 plus 16i. Okay? 6 plus 16i. Okay, and we're going to go to the next one. Negative I times negative 2. Negative times negative is positive, and I times 2 is 2i. Negative I times positive 10i. Well, negative times positive is negative 10, and then I times I squared. All right, so let's clean this up some. What did we just say about I squared? It equals negative 1. What will negative 1 do to negative 10? It'll make it plus 10. So my real part is 10, and my imaginary part is positive 2i. So 10 plus 2i. All right, let's make this a little bit more complicated. Let's start distributing. And I'm just going to go down here. So here we go, number 8. What is 2 times negative 5? 2 times negative 5. Well, that's negative 10, right? Negative 10. Well, what about 2 times negative 3i? 2 times negative 3i is negative 6i. All right, moving on. What's negative 4i times negative 5? Well, negative times negative is positive. 4i times 5 is 20i. And then lastly, how about negative 4i times negative 3i? Well, negative times negative is positive. 4 times 3 is 12. And I times I is I squared. Remind me, what does I squared equal? Negative 1. So 12 times negative 1 minus 12. So here we go. Ready? Here's my like terms. What's my real part, guys? Hopefully you said negative 10 minus 12. Well, what is negative 10 minus 12? Negative 22. And then we have our imaginary parts, which are negative 6i plus 20i. Or reverse that, 20i minus 6i. 20i minus 6i is positive 14i. So my answer in standard form is negative 22 plus 14i. Okay? I want to do 9 and 10 both. 9 for one major reason. Don't forget, you don't go 6 squared and negative 2i squared. A lot of people make that mistake, and I don't want you guys to do it. Remember what 6 minus 2i squared means. It means we're doing 6 minus 2i times 6 minus 2i. So let's do our distributive property. Ready? 6 times 6, 36. 6 times negative 2i, negative 12i. Negative 2i times 6, negative 12i. And finally, negative 2i times negative 2i. Okay, well, negative times negative, positive. 2 times 2, 4. I times I squared, or negative 1. Negative 1 times positive 4 is negative 4. So let's see our like terms. Ready? What's 36 minus 4? 32. And what is negative 12i minus 12i? Negative 24i. So my answer in standard form is 32 minus 24i. All right, move on to number 10. It's got a little trick to it, but nothing we can't handle. Watch this. What's 1 times 9? 9. What's 1 times 3i? 3i. What's 7i times 9? 63i. And what's 7i times 3i? Well, positive 7 times positive 3 is positive 21. I times I is I squared. So let me write all this down. Don't forget about all that over there. So remember, what do we know about I squared? Negative 1. So what does it make this term? Minus 21. So here's what we have in our first grouping. We have 9 minus 21. 9 minus 21 is negative 12. But we also have 3i plus 63i, that's 63i, or I'm sorry, 66i. And then we have this minus 4 minus 2i. So here we are. Let's finish this thing up. We've got negative 12 plus 66i. What will this minus do to this 4? Make it negative 4. And what will this minus do to this negative 2i? It'll make it a positive 2i. So my answer in standard form is negative 4 minus 4, negative 12 minus 4, negative 16. And 66i plus 2i is plus 68i. Okay? You know what? I just recognized that I made a mistake, didn't I? If you notice back over here, this was not a minus, this was a plus. This was a plus. So it actually would have made that a minus. I'm sorry I missed that. So negative 12 minus 4 does equal negative 16, but 66i minus 2i would leave me with 64i. So please apologize, I just noticed that, and obviously that made a difference. So there's number 10, okay? Hopefully you guys understand, without any real issue, how to add and subtract like terms when it comes to complex numbers, and also how to multiply, okay? Now let's go to the back and let me show you these properties, which is really simple, I promise. And then I'm going to show you number 15, how those are used on 14 through 16, and then I want to do number 18 with you. So pay attention with me. Commutative property. Commutative property says this. It says if I had 2i plus 3i plus 4i, that is the same as doing 3i plus 4i and then adding the 2i. So I want you to notice what we did. We moved the 2i from the left all the way to the right. What we did was we changed order. That's what the commutative property says, that order can change and it won't affect anything. Order changes, doesn't affect anything. Now I want you to listen carefully to this. When does commutative property work? Well, it works with two of your mathematical operations. Commutative property works only with addition and with multiplication. You can't just change your order in subtraction, it'll mess your problem up. You can't change your order in division, it'll mess your answer up. But with addition and multiplication, order doesn't matter. So that's what that rule is. The next rule is the associative property. And here's what it says. It says that if I took 2 times 5i, and then I multiplied it by 3i, it's the same thing if I took 2 and I multiplied it by the result of 5i times 3i. You notice what I did there? On the left side, I had 2 times 5i grouped, and the 3i was outside. On the second side, 2 was on the outside, and 5i and 3i were grouped. Associative property is when your group changes. Your grouping changes. Now, once again, think about this, guys. When does associative property work? It works with addition and multiplication, and that's it. Okay, the last one you're golden on, distributive property. Here's what it says. If I have 2i times 3 plus 6i, I am taking 2i and I'm distributing it to 3, and then I'm taking 2i and I'm distributing it to 6i. That's the distributive property. That's something that you guys are really good at. So let's look through these real quick. Look at 14 with me. Look carefully at it. Look at what's happening. You got 2i times 7 minus 5i, and that equals 2i times 7 minus 2i times 5. Which of these three properties is being shown here? I hope that you said distributive property. That's exactly right. This is the distributive property. Look, 2i is being distributed to both 7 and to negative 5i. Okay, look at 15 with me. What happens? Does order change or does grouping change? Well, I hope you see that grouping changes. So this one is associative property. And then finally, and I guess you probably know what this one's going to be, but I want you just to notice it. Does order change or does grouping change? Well, definitely order. Look how that 8i moved from the back to the front. So this one is commutative property. So on the homework tonight, you're going to have to actually write a couple of those. So don't stress it, but I do want you to come up with your own. Okay? So let's look at number 18. Let me just show you how we incorporate what we learned today into what we have done up to this point. Here I'm going to subtract 10, right? Hopefully you guys know how to solve equations by this point. So we have 2 times x plus 1 squared equals negative 10. Then I'm going to divide by 2. So x plus 1 squared equals negative 5. So when I take the square root of both sides, this is where we did yesterday. We did the plus or minus, but then the negative comes out as a I, and that 5 gets trapped inside. Now here's why this problem is a little bit different. You notice how the x plus 1 was being squared? So it was still left over there on the left side. So what I need to do is I need to move it to the right side by subtracting it, and I'm just going to put it up front. And it's going to say negative 1 plus or minus I squared root of 5. Now sometimes people struggle with this, so this is what I try to say for them to understand it. Because you can't combine negative 1 with I squared root of 5, you have 2 complex solutions when you put it out front. You have your real part, negative 1. Then you have the 2 solutions, plus and minus, and then you have your imaginary part, I squared root of 5. So that is why this is the solution. So that is how you do this. We added and subtracted like terms. We multiplied and combined like terms. We went through properties that you've learned in the past, picked out how they're being used, and then we looked at a problem here, number 18, where your solution is a complex number. All right, so finally, your homework. If you look, or if you get this worksheet that's coming your way, or maybe you already have it, your homework tonight is numbers 2 through 16 even, but also I want you to do number 11 as well. So that is the whole right side plus number 11. So that's your homework tonight. I hope that you do a great job on it. You have some time right now to work in class, so I encourage you guys to do that. I hope you have an awesome weekend, and we'll see you soon.